triangles ABD and BCD are right angle triangles. And the question says we need to work out the value of x, giving our answer correct to 2 decimal places. So essentially the question is asking us to work out the length of this side here. Now the first thing that jumps out to me, because we're working with the right angle triangles, is Pythagoras Theorem. Now a quick reminder of what that is. So this works with right angle triangles. So if we got this side here to be A, this side here to be B, and this side here to be C, it states that A squared plus B squared equals C squared. So if we know these two lengths here, we can work out this length. So we can implement that and use that to work out what x is here. The issue we currently have is we don't quite have enough information to work out this x, because we only know one side from this triangle, BCD. We only know 4 centimeters. However, to use Pythagoras' theorem, we need 2 bits of information. So we're going to use this triangle, which does have 2 bits of information, to work out this side, which then gives us 2 bits of information to be able to work out x. So hopefully it will make sense as I go along. So I'm going to label this side y centimeters. And if we refer over to Pythagoras' theorem over here, for this triangle, so for triangle ABD, we're going to say y squared plus 5 squared equals 10 squared. So now we can rearrange this. We're going to make y squared the subject. So we're going to subtract 5 squared from both sides. We're going to have y squared equals 10 squared minus 5 squared. And we're going to say y squared equals. I'm going to put this into the calculator to find out what it gives us. And we get 75. So we know that y squared equals 75. And I could go further and try and get y by itself and square root both sides. However, I'm not going to do that. And you're going to see why later. That's an irrelevant step and there's no point doing it. So we're now going to work with this triangle here. So for triangle BCD, and what we're going to have there, we're going to have y squared plus 4 squared equals x squared. Now, what we can see here, we've got y squared here, but we know, because we worked out in the previous step, what y squared is. So we can sub that in, and we can see why we didn't square root this now, because if we did, we'd just have to square it again. So using y squared equals 75, we're going to have 75 plus 4 squared equals x squared. And if we work out what 4 squared is, that's 16. So we've got 75 plus 16 equals x squared. And if we add these together, so that's 91. So I'm going to write it the other way around so it makes a bit more sense. We've got x squared equals 91. And so to get x, we're going to square root both sides. So what is important to note here is because we've got an equation here, and we're going to square root, we're going to introduce a plus or minus. So we're going to have plus or minus the square root of 91. Now this, because conventionally, just the square root symbol, that will give us the positive square root of a number. But because we've got an equation here, x could either be positive or negative. So we've got to put this plus or minus outside of the square root here. So we need to think about this for a second. We've got 2 answers for x. So which one's it going to be? Well, in the context of the question, we're looking at a length here. So it's going to have to be positive because you can't have a negative length. So I've written that out here. So x is a length. So we're going to reject negative the square root of 91. So x is just equal to the square root of 91. But looking back at the question, say give our answer correct to 2 decimal places. I'm going to put that into the calculator, square root of 91, and to 2 decimal places, that will be 9.54. Great, and we're just going to write that into the answer box. So seeing where we get the 4 marks, we get the first mark up here for getting to the y squared being equal to 75. Second mark down here for this part, so we got the 75 plus 4 squared equals 91. We get our third mark for square rooting to make x the subject of the equation. Then we get the fourth and final mark for a correct answer of 9.54.